DeepSeek doesn't stop amazing us. Yesterday they dropped another model, and it almost feels like the first DeepSeek moment all over again. It raised its Artificial Analysis Intelligence Index score by 10 points, beats its Pro version on every benchmark while being roughly 5 times smaller, and the pricing is a whole different story on its own. So in today's video, we'll look at how this model is actually performing, or if it's just benchmaxed, its price war with other cheap models, what actually led to this jump in performance, and how you can access it. The new model is DeepSeek V4 Flash 0731. This is not a new model trained from scratch with a new architecture. It's the same previous DeepSeek V4 Flash, repost-trained with a massive emphasis on agentic capabilities, coding, and tool use, so there's no change in specs at all. Same 284 billion total, 13 billion active parameters, same 1 million token context window, same attention design, same residual connections, but the performance tells a different story. Let's look at some benchmark results. On Terminal Bench 2.1, it scored 82.7. For comparison, the previous V4 Flash scored 61.8, roughly a 20-point jump. And their biggest flagship, V4 Pro, a 1.6 trillion parameter model, scored 72.1, about 10 points behind. When we compare it to other labs models, it beats GLM 5.2's 81, and scores just below Opus 4.8's 85. On DeepSeek, the previous version was at 7.3. The new release jumped to 54.4, literally a 7x performance leap. For the same test, GLM 5.2 is at 46.2, and Opus 4.8 is at 58.0, so it loses to Opus again. On NL2 repo, which tests whether a model can build or modify an entire code repository from a plain language description, not just a single function, the previous Flash was at 39.4. The new one jumps to 54.2, about 15 points higher, and this time it also beats V4 Pro's 38.5 by a wide margin. GLM 5.2 sits at 48.9 and Opus 4.8 leads at 69.7. Overall, it beats its previous version and the Pro flagship model on every single benchmark and performs near Opus 4.8 level despite being significantly smaller and cheaper. One thing worth flagging here, DeepSeek ran these code agent tests using their own harness, which they haven't released publicly yet. So until someone outside DeepSeek can run the same test, take these specific numbers with a bit of caution. That's actually why the next set of numbers matters more. Artificial Analysis, an independent group that runs every model through the same tests, published their own evaluation. No vendor picking favorable benchmarks here. On their intelligence index, DeepSeek V4 Flash 0731 landed at 50, up from 40 for the old Flash. A real 10-point jump on the exact same architecture, the exact same price. That's rare. Usually a jump like this needs a bigger model or a higher price tag, not just retraining. It puts V4 Flash 0731 basically neck and neck with GPT 5.6 Luna and GLM 5.2, both at 51, and right next to Gemini 3.6 Flash at 50. It's still 7 points behind Kimi K3, which stays the open weights leader at 57. So this isn't a best in the world claim, it's a best value in the world claim. And then there's GDPvo AAV2, Artificial Analysis's benchmark for real-world work tasks measured in ELO. The old Flash was at 1189. The new one jumps to 1559, a 370-point swing. That would put it as the second highest scoring open weights model on this test, behind only Kimi K3's 1687, and ahead of GLM 5.2's 1510. One honest caveat from Artificial Analysis though, this model is verbose. It used about 206 million tokens to complete their full test suite, against a median of 100 million for other models. So it thinks a lot before answering, which eats into some of that price advantage in practice. We'll get into that more when we talk pricing. Outside of raw intelligence, DeepSeek also showed up strong on Arena.ai's front-end code Arena, which ranks models purely on how good they are at building working front-end interfaces. V4 Flash landed at rank 7 overall, and rank 3 among open-weight models, with a jump of 154 points over its own preview and 121 points over V4 Pro preview. For a model this cheap, landing in the top 10 for front-end code is a big deal. Now let's talk pricing. DeepSeek didn't raise a cent for this update. V4 Flash 0731 still costs 0.14 per million input tokens and 0.28 per million output tokens, exactly the same as the April preview, despite everything else that changed. The more exciting part is the cash. If your input hits the cash, you're paying 0.0028 per million tokens, a 98% discount, steeper than the roughly 90% you'd normally get from cash pricing elsewhere. For anything running in a loop, agents, coding assistants, anything reusing context, that ends up being close to free. We had a similar update from Luna recently too, so let's see how this stacks up. The day before DeepSeek's release on July 30th, OpenAI cut GPT 5.6 Luna's price by 80%, from $1.06 per $1 million tokens down to 0.20 and 1.20 just 3 weeks after Luna launched. OpenAI said it was passing on efficiency gains, though Chinese models had grabbed 46% of US enterprise token usage on OpenRouter just days earlier. Even after that cut, V4 Flash still comes in cheaper on both ends. 0.14 versus Luna's 0.20 on input, 0.28 versus 1.20 on output. That's roughly a quarter of Luna's output cost, for a model sitting within a single point of it on the intelligence index. But sticker price alone isn't the full story. Cost per task is what actually matters. And this is where that verbosity caveat from earlier comes back in. This model uses about 206 million tokens to do work other models finish in around 100 million. So while the per token price looks like a massive gap, the real gap shrinks once you account for how much more it writes before answering. Even after that adjustment, artificial analysis still puts it roughly 60% cheaper than Luna for comparable output quality. Real savings? Just not the 4 or 5 times cheaper the raw token prices alone suggest. And it's not getting worse either. This same benchmark Squeak took 234 million tokens on the preview, so 206 million is actually a 12% drop. It's leaner than it used to be, just still wordier than most of the field. But how did this happen without changing the model's size or architecture at all? The short answer is post-training. When a model gets trained, there's usually 2 stages. First is pre-training. The model reads through trillions of tokens of text and picks up language, facts, patterns, reasoning, all of it. That stage didn't change here. It's the exact same base model DeepSeek trained back in April. The second stage is post-training, and this is where DeepSeek actually did the work. Instead of training one model on everything at once, they trained separate specialist versions first. One focused on coding, one on math, one on agent tasks, and each of those gets pushed through reinforcement learning on its own, where the model attempts a task and its work gets checked automatically. Say it's fixing a bug in a codebase. Does the code run? Do the tests pass? If yes, the model gets reinforced toward whatever led to that outcome, and if not, it learns to avoid it. Once each specialist is sharp on its own domain, they all get merged back into a single model, more like a student learning from several teachers at once than copying one. This probably also explains why some benchmarks jumped so much harder than others. DeepSWE is about fixing real GitHub issues, and a fix is either correct or it isn't, the test suite passes or it doesn't. That kind of clean pass-fail signal is exactly what the coding specialist would have been trained hardest on, which likely explains why it went from 7.3 to 54.4. Something like Agent's last exam, a broader test that grades messier, more open-ended agent behavior instead of a clean pass or fail, moved by a lot less in comparison, probably because there's no clean signal like that to train against as easily. So nothing about what the model knows actually changed. What changed is how it's been trained to act on what it already knew. So is it actually benchmaxed? Doesn't look like it. Artificial analysis ran their own separate tests, nothing to do with DeepSeek's benchmarks, and it still jumped 10 points there. If this was just trained to ace the published numbers, that gain wouldn't carry over to a test it's never seen before. And from my own testing, plus what the community's been reporting, the real-world results hold up too. This genuinely feels like a great model. So if you're wondering how to actually get your hands on it, it's live right now through DeepSeek's API, same endpoint as before, so if you were already calling it, you're automatically on this version. It also just picked up native support for the Responses API format, and it's been specifically adapted for codecs, so it slots into a lot of existing agent setups without needing a translation layer in between. There's also 3 effort levels now, low, high, and max, basically how much the model thinks before answering. Low is fast and cheap, max can run all the way up to 384,000 tokens of output for something that actually needs to reason through a hard problem. And if you want to run it yourself, the weights are on Hugging Face under MIT license, free for commercial use. Just know it's not a small download. The full checkpoint is around 167 gigabytes, and even though only 13 billion parameters are active at once, all 284 billion still have to sit in memory. Quantized versions exist if you don't have that kind of hardware, down to about 160 gigabytes at 8-bit or around 100 gigabytes if you go more aggressive. For weeks now, there's been a rumor that DeepSeek V4 Pro's final version is coming, and it's been anticipated for a while. V4 Pro hasn't been through this kind of retraining pass yet, it's still running on the April version. If the same treatment lands there, and there's no real reason to think it won't, this Flash release could end up being the smaller story by the time Pro ships. One thing worth keeping an eye on if you're actually building with this. DeepSeek has announced peak hour pricing. doubling every rate during 2 windows tied to Beijing business hours. No date's been set for when that kicks in, so the pricing we walked through today isn't guaranteed to hold, and depending on when your workload runs, that could change the math quite a bit. Another thing worth noting, it's not multimodal. So if your project involves any visual work, reading screenshots, images, anything like that, you'll need to pair it with something else for that part. Overall, DeepSeek isn't holding back even a little. They're constantly pushing great releases. In my opinion, they're more scientifically grounded, more aligned, and pushing more real architectural change than other open source labs out there right now. We saw this recently with the DSpark release 2, which sped up generation by 60 to 85% without touching the model itself. And the day before this release, DeepSeek was reported to be adding a full gigawatt of compute in Inner Mongolia. So between that, a retrained model beating its own flagship, and a pricing experiment nobody else in the industry is trying, it's pretty clear DeepSeek isn't just shipping updates anymore. They're playing a much longer game. That's where things stand with V4 Flash 0731 for now, but if what we talked about today is any sign, this probably won't be the last DeepSeek video for a while. If you found this useful, stick around for when V4 Pro actually drops, because that one might be an even bigger deal. Thanks for watching, and I'll see you in the next one.